Hi students, in this video we're going to cover composition of functions. So let's start with an example. A clothing store has its jeans priced according to the function f of x equals 65x plus 1.06, and you have a coupon for 20% off your entire purchase. You need to write a function for your final price, or like whatever you're gonna pay. All right, so first let's come up with a function for number 2. So you taking 20% off your entire purchase, that's like paying, that's like having 0.8x. So if x is the total price, x minus 0.2x, which equals 0.8x, is the discounted price. So we have this other function. We're going to say g of x equals 0.8x. So now we have our two functions. G of x equals 0.8x and f of x equals 65x plus 1.06. So if you buy the jeans, however many jeans you buy, then like say we buy one pair of jeans. So we know like f of 1 is going to equal 65 times 1 plus 1.06, which equals 66.06. Don't freak out. And so then the discounted price is going to be G of 66.06, which is 0.8 times 66.06. Now, I'm not that great at math, so let's go to the calculator. So we want to do 0.8 times 66.06. So that's going to be $52.85. So we want to have, I forgot, I think it was 52.85. All right, so a composition of functions is when you take a value from one function and use it in another function. The other way we could have done this is we could have done the function backwards. We could have done the function g of f of x, because we needed the value for f of x before we could evaluate g of x. So if we'd done the function g of f of x, that would have been 0.8 times 65x plus 1.06. And you can see that if we still did g of f of 1, that's just going to equal 0.8 times 65 times 1 plus 1.06, which still simplifies to be 0.8 times 66.06. We end up doing the same calculation, but just in one step. And so this is a composition of functions. You take a function, you substitute it into another function, and that function is those two functions are interacting with each other. So there are a couple of notations that we have for composition of functions. We have f, this little circle that means composed with. Let's make a note here. This symbol means composed with. So f composed with g of x means you need to substitute g of x in for each x in f of x, and g composed with f of x means substitute f of x for each x in g of x. The alternate notation you may see is either f of g of x or g of f of x, depending upon which thing you have to compose. It's a very straightforward process that just requires some algebra. So our first example is h of x equals f of g of x, and we need to find h of x. So if we have f composed with g of x, that means that we need to do f of g of x is going to equal, so we have 3, and everywhere there's an x, we're going to substitute in x squared minus 1. So that's going to be 3 times x squared minus 1. And then we still need to subtract 1, because f of something means you multiply it by 3 and then subtract 1 from it. So when we simplify, we get 3x squared minus 3 minus 1. So that's going to simplify to be 3x squared minus 4. So that's f of g of x. Now, we could have done g of f of x, and that would give us, so now everywhere we have an x, we want to substitute in f of x. So that's really like doing f of x, just so we're clear, so f of x squared minus 1. But f of x is actually 3x minus 1. So 3x minus 1 squared minus 1, and that's going to equal, you can trust me on this, it's going to be 9x squared minus 6x plus 1 minus 1. So plus 1 minus 1, really we're just going to get 9x squared minus 6x. So now notice the composition, f of g of x is not equal to g of f of x, and that's going to be standard. So next we have j of x. Actually, I guess we did this already. So j of x is g of f of x, and that's the example that we did here, but for posterity's sake, we can just quickly do it again. So g of f of x, again, is g of f of x. That is 3x minus 1 squared minus 1. And so now we can fully work this, so you see that we actually do get the same thing we got on the previous slide. So that's going to be 9x squared minus 3x minus another 3x and plus 1 minus 1. So we get 9x squared minus 6x as our final answer. So that's g of f of x. Now again, generally, f of g of x and g of f of x are not equal to each other. The next example we have is, say you actually have to find a value doing this. So we have g of f of negative 1. So g of f of negative 1. So this requires that we first find f of negative 1. So f of negative 1 is negative 1 squared plus 1, which equals 2. And so this is the same as doing g of 2, because f of negative 1 was 2. So now g of 2 is going to equal, let's see, so g of 2 is 2 squared plus 2 times 2. So that's 4 plus 4 is 8. So g of f of negative 1 is equal to 8. And so now we're doing the same thing, but we're doing f of g of negative 1. So f of g of negative 1 is going to equal, let's see, g of negative 1 is equal to negative 1 squared plus 2 times negative 1, which is negative 1. Because that's going to be 1 minus 2, which is negative 1. So what we need to really find is f of negative 1, which is 2. So f of negative 1 is going to equal negative 1 squared plus 1, which equals 2. So f of g of negative 1 is equal to 2. So again, notice that g of f of negative 1 is not f of g of negative 1. We got two different values. This value was 8. That value was 2. So obviously 8 isn't equal to 2. So in general, those two things do not equal. The next example we have is, say you have a set of values where we have f is these four ordered pairs, and g is the second set of ordered pairs. And we have to do f for a, we have to do f of g of 3. So now that means we need to do f of g of 3 is 5. So we actually need to find f of 5. So f of g of 3 is equal to f of 5 because g of 3 is 5 and f of 5 is 6. And so then if we wanted to do g of f of 2. So f of 2 is 3. So g of f of 2 is actually equal to g of 3 because f of 2 is 3 and g of 3 is 5. So g of 3 is equal to 5. So our final answer is 5. And lastly, we can compose a function with itself. If we do f of 1, that's going to be f of 1 is 2. So we're actually finding f of 2, and f of 2 is 3. All right. And so the last example is you could also have a graph where you can still do composition. So for A, we're doing f of g of 0. So g of 0 is the function value when x is 0 for g of x, and that's going to be 0. So f of g of 0 is the same as f of 0, and f of 0 is 4. So f of 0 equals 4. For letter B, we have g of f of 3. So first we need to find f of 3. So f of 3 is 3. So then we get g of 3. And g of 3 is 0. I'm going to take all these and color that. So for letter C, let's change this color up a bit. So we have g of f of 4. So g of f of 4 is equal to, so f of 4 is 4. So then we want to do, I'm sorry, I did that backwards. It's g of f of 4. And why am I highlighting? It's g of f of 4, which means we need to do f of 4 first. F of 4 is 0. So we want to do g of 0, which also equals 0. G of 0 is here. So then last we have f of g of 1. So g of 1 is 3. And then f of 3 is equal to 3. All right, so that concludes our video on composition of functions. It is substituting one function in for another function. If we have a function, if we have values, it means you substitute the value into the inner function first and then work with the outer function.